type of roots. What is discriminant? Discriminant is usually denoted by D. From the quadratic equation ax squared plus bx plus c equals to 0, we can determine the type of roots of the equation by substitute the value of b, a, and c into the formula b squared minus 4ac.
Two real and distinct roots. If the value of discriminant is more than 0, then the quadratic function has two distinct real roots. In the example given, determine the type of roots of each of the following quadratic equations without solving the equation. The picture below shows the question. We can see in the solution from solving the equation, we will get 17. This shows that the value of discriminant is more than 0. Hence, the equation has two real and distinct roots.
Next, we have two equal roots. The discriminant of two equal roots is b squared minus 4ac equals to 0. Types of roots are two real and equal roots while the position of the graph is the graph touches the x-axis at one point only. Position of graph of function fx equals to ax squared plus bx plus c. On the left diagram, since a is more than 0, thus the graph of fx passes through the minimum point and intersects the x-axis at one point. While on the right diagram, since a is less than 0, thus the graph of fx passes through the maximum point and intersects the x-axis at one point.
And the last one is, we have no real roots. The discriminant for no real roots is b squared minus 4ac is less than 0. Types of roots is no real roots, while the position of the graph is the graph does not touch the x-axis. The graph shown on the left side, since a is more than 0, the graph will always be above the x-axis since function is always positive. However, it will not touch the x-axis. And for the graph on the right side, since a is less than 0, the graph will always be below the x-axis since function is always negative. However, the graph will not touch the x-axis.
Equation here is 2x squared plus 5x minus 3. So as we can see, the value of a is more than 0, which is 2. So the graph will show the smile face. So if we change the value of a, let's say it is negative 2, it will appear the sad face.
So as you can see here, the equation shows that the value of a is less than 0 and the b is more than 0. So the graph will shift to the right. But if the value of a is less than 0 and the value of b is less than 0, the graph will shift to the left.
From the equation, you can see that the value of c is negative 3, which is less than 0. Thus, the graph form will shift downwards. If the value of c increases, for example, plus 3, the graph will shift upwards.